Hello my dear students, today class we are going to discuss the +2 chapter electromagnetic induction. In that the topic name is transformer. Name of the topic is transformer. What is a transformer? Transformer means a transist something. Now we are going to study about the electrical topic. So it transforms the electrical energy. So transformer is a device transform energy. What energy? It is electrical energy. So there are two kinds of the transformer. One is step-up transformer, another one is step-down transformer. Now we are going to classify later. First, what transforms? A device, so it is an electrical device which transforms electrical energy. That means, which transform alternating voltage into alternating voltage. So the transformer transform alternating voltage to alternating voltage. That means high alternating voltage into low alternating voltage, or low alternative voltage into high alternative voltage. So the transformer change the voltage from high to low. Not only the voltage and as well as the current also. If one of the device, there is an electrical device that transform the alternative voltage, that means high alternative voltage into low alternative voltage, same times current also changes. Current transform. So high alternative voltage into low alternative voltage with low current into high current. So the transformer transits not only the voltage but also the current. Where the voltage is higher, where the current is low. Where the voltage is low, where the current is high. So that is why we can classify the transformer into two categories. One is step up transformer. Second one is transformer. What is a step up? Step up, that means low voltage into high voltage. That is called a step up. Step down, high voltage into low voltage. So the step up transformer, high voltage with low current into low voltage with high current. Step down transformer, low voltage with high current into high voltage with low current. So the transformer can be classified into two categories. One is step-up transformer, step-down transformer. Generally, transformer, it is electrical energy which converts voltage, high voltage into low voltage or low voltage into high voltage. The classification of transformer, step-up transformer. In the case of step-up transformer, it transforms high voltage with low current into low voltage with high current. But step-up, step-down transformer, it step down. It reduces the voltage. Low voltage with high current into high voltage with low current. So these are the two classifications of the transformer. Now let's see the construction of the transformer. Construction. Construction of the transformer. Schematic diagram. Schematic diagram of the transformer. Transformer consists laminated core. It's made up of either steel, that's a silicon steel, or any other magnetic material. So this is laminated core. There are number of laminated cores placed one over another. It is laminated with the help of silicon steel or any other magnetic material. Why? Why it is laminated? Because to reduce eddy current, we know that eddy current, due to the eddy current there may be the loss of energy. To reduce the energy, we are laminating the core of the transformer with the help of suitable material like a silicon steel or some other magnetic material like a mu metals. Silicon steel is made up of the silicon steel. It is completely laminated. Completely laminated. But another one more. One end of the transformer, the laminated core, is connected wound with some number of turns. These turns connected to one end. Again, another turns of the coil is connected another end. Both are coils with wound with number of turns. It's also the number of turns. One end is connected with AC supply. So, where the input is given to the terminal is called primary. Primary coil or primary turns. Where the input is given, the terminal is called primary coil or primary turns. Where the output is taken, it is a secondary coil or secondary turns. There are two types of the turns which are electrically insulated, but they are not contact to one another. There are two different turns. One is connected to the one end of the laminated core, another end is connected another laminated core. Both are not connected, but electrically insulated, magnetically linked. Electrically insulated, magnetically linked. Where the input is given to the coil is called primary coil. Where the output voltage is taken out, that is called secondary coil. So primary coil, secondary coil, the number of turns are not equal. We will talk later. The number of turns in the primary coil is not equal to the number of turns in the secondary coil. That's why I mentioned 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 and so on. If the both coils are same, what happened? We'll talk later. So this is the primary coil. This is the secondary coil. So the input is given to the primary coil. The output is taken out across the secondary coil. Both coils are electrically insulated but magnetically linked. But the entire core of the transformer plays in suitable medium like some other liquid to reduce the heat. Okay, this is the construction of the transformer. How the transformer works? What is the principle involved in a transformer? Now what we are going to study about the transformer. So transformer is an electrical device which converts electrical energy. That means low voltage into high voltage or high voltage into low voltage, where the low voltage is used, where the high voltage is used. Suppose, for example, this is a AC signal. That's an alternating signal. Alternating signal given to the input terminal through the via input terminal. So this is primary coil or primary turns. Primary coil or primary turn. So denoted by symbol Vp. Vp represents input voltage. We know that already we have studied the self-induction, mutual induction, electromagnetic induction. We know that what is electromagnetic induction? Whenever there is a changing the electric lines of force or flux linking with the coil, EMF is induced. So in this case, already we have studied mutual induction. Mutual induction. So this is one of the coil, another coil. When AC signal or when current passes through the primary coil, the flux changes. The flux linking with the secondary coil. So if there is a changing the current, flux changes. The flux changing linking with the secondary coil. So there is a change in the EMF induced across the coil. So the EMF is called induced EMF. So this is a process called mutual induction. So the mutual induction, there is no motion of the coils. Like when AC passes through the one of the coil, continuously varying current, alternating current, continuously from 0 second to peak, then again 0, peak 0. Every instant of time the current varies. Value 0 to peak and 0 to maximum to 0, 0 in opposite direction, maximum again opposite direction to 0, continuously varying its magnitude. So when current continuously varies in this coil, flux linkage, there is a changing the flux. If there is a changing the flux, EMF is induced. That is, EMF is EP. Vp represents applied voltage of alternative voltage. When current changes, EMF is induced in the coil. But the same time, secondary coil is wound on the laminated core. It's very close to the primary coil. When the flux changes in the primary, the same amount of the flux changes in a secondary also. When the flux changes in the primary, same amount of the flux changes in a secondary. So mutual induction takes place. So the principle used in the transformer is mutual induction. Principle used in the transformer, mutual induction. When the current changes, the flux changes. If the flux changes, EMF is induced. But EMF is induced between the pair of the coils. So applied voltage Vp, EMF induced in the primary coil is EP, Vp applied voltage, EP induced voltage. EMF is induced. But secondary coil is very close to the primary, same amount of the flux linking with the secondary. If suppose there is no change in the current, there is no change in the flux. If there is no change in the flux, there is no EMF is induced. So there is no mutual induction takes place between the pair of the coil. Actually, mutual induction nothing but static. No coil changes the position. Simply they are at rest. Even the coils are rest. The flux changes, EMF is induced across the two coils. So EMF set up between the pair of the coil. So applied voltage VP, induced voltage EP. The same flux linking with the secondary coil. So ES. That is ES. The voltage taken out across the coil is VS. So VP applied voltage, VS obtained voltage across output, EP induced voltage in a primary coil, ES also induced voltage across a secondary coil. So both the fluxes are equal. If there is no change in the flux, there is no leakage of the flux. There is no leakage of the flux. In order to leakage from the coil, completely laminated, completely covered with some of the covering papers to reduce leakage of the flux. If there is no leakage of the flux in outside, entire flux changes in the primary linking with the secondary. But changing the flux, if changing the flux in a primary is called frequency. So the varying a flux, magnetic flux across a primary, so the frequency of the primary is equal to frequency of the secondary. So frequency across the primary which is equal to frequency across the secondary. That means changing the flux in primary in a given interval of time, same interval of time the flux changes in the secondary. So the frequency remains same. Frequency remains same across the both coil. So EMF is applied, voltage is applied across the primary coil. EMF is induced across same primary coil. So the same flux linking with the secondary coil ES, voltage obtained across output is VS. We know that according to the Faraday laws, whenever there is a change in the magnetic flux linking with the coil, EMF is induced. Rate of change of magnetic flux with the coil, rate of change of magnetic flux directly proportional to induced EMF. We know that E is equal to d pi by dt according to the Faraday. According to the Faraday. With the help of the Faraday and the lens. So lens explain direction of the induced EMF. Faraday did not explain what is the direction of the induced current, but the lens explain what is the direction of the induced current. Direction of the induced current always opposed to cause. So always opposed to change. Where the flux changes, the EMF induced opposed to change the cause, opposed to change, opposed to cause. So E is equal to minus N d pi by dt. So minus sign indicate that direction of the induced current. So E represents induced EMF. Rate of change of flux. Rate of change of flux directly proportional to induced EMF. So minus sign indicate that direction of the induced current. So here instead of E, I am taking EP. EP. That's a EP. So induced EMF EP is equal to NP. So NP represents number of turns in primary. NP, number of turns in primary. D pi by dt. Flux changes across the primary. Similarly, ES. What is the ES? ES across the secondary. ES equal to NS d pi by dt. What is the NS? Secondary turns NS. So minus. It is a minus. So direction of the induced current always supposed to cause. So it is induced EMF. Induced EMF is equal to minus NP d pi by dt. ES equal to minus NS d pi by dt. See that? D pi by dt. Changing the flux with respect to time. Changing the flux in primary, secondary are equal. That's why the frequency equal in both the primary and the secondary. Rate of change of flux linking with the primary and the secondary are equal. Secondary are equal. So we know that EMF induced across the primary is equal to applied EMF but opposite direction. VP applied voltage directly proportional to EP, EMF induced across primary but in opposite direction, minus EP. Similarly, voltage taken out across secondary is equal to EMF induced in a secondary but in opposite direction. Vs is equal to minus Es. Both are same. Applied voltage is equal to induced voltage. Induced voltage across secondary is equal to obtained voltage across the output, across the secondary coil. Across secondary coil. We know EP is equal to minus NP d pi by dt. E is equal to minus NS d pi by dt. Vp is equal to minus EP. Vs is equal to minus Es. Now compare. Compare the equation. Vs by Vp is equal to Es by EP. Vs equal to Es, Vp is equal to Vp. So EP is equal to minus d pi by dt. E is equal to minus Ns divided by d pi by dt is equal to Ns d pi by dt Np d pi by dt. Both are cancelled because the changing the flux across the primary coil, primary and secondary are equal. So Vs by Vp is equal to Es by Ep. Vs by Vp is equal to Es by Ep is equal to Ns by Np. So Ns or Es by Ep is equal to Ns by Np. Es represents EMF induced across secondary, which is equal to applied voltage, or Vs by Vp is equal to Ns by Np, because Es which is equal to Ep, Vs which is equal to Vp. So Vs by Vp or Ns by Vs by Vp is equal to Ns by Np. Vs represents applied voltage across the primary. Vp represents obtained voltage across the secondary, which is equal to number of turns in secondary and primary. So Vs directly proportional to Ns, Vp directly proportional to Ns. In this case, number of turns in primary directly proportional to Vp. Voltage applied across the primary. Voltage applied across the primary is equal to number of turns. If number of turns increases, voltage across the primary also increases. Similarly, voltage across secondary is directly proportional to number of turns across the secondary. So number of turns increases, voltage is also increases here. So voltage and number of turns are directly proportional. So Np directly proportional to Vp, Vs proportional to Ns. Both number of turns. So Vs by Vp is equal to Ns by Np. So this is equal to K. What is K? K is called transformer ratio or turn ratio. Transformer ratio or turn ratio. K represents transformer ratio or K ratio. So transformer ratio is Ns by Np, Vs by Vp. In the case of ideal transformer, we know that input power which is equal to output power. Input power which is equal to output power. What is the formula to calculate the power? Power. P is equal to the product of the voltage and the current. So P is equal to VI, general formula for power. P is equal to VI. Input power which is equal to output power. How? Here, where the voltage is greater, the current is lesser. If the voltage changes, high voltage changes to low voltage, same times low current converted into high current. Okay, the voltage increases, current decreases. Okay, the voltage decreases, current increases. If you product, both are same. So input power which is equal to output power. The magnitude of the power across the primary which is equal to magnitude of power across the secondary. So in the case of ideal, not all transformer, only in ideal transformer, input power which is equal to output power. We know that world of transformer, transform high voltage into low voltage, or high voltage with low current into low voltage with high current. So P is equal to VI. Input power, power input is equal to V primary, P primary, V primary, I primary, PS secondary power, V secondary, I secondary. So primary power is equal to secondary power. In the case of ideal transformer, the input power, P represents input, that's the primary, S represents secondary, that's the output. Input power which is equal to output power. So input power VP IP is equal to VS IS. VP IP is equal to VS IS. So voltage increases, power, voltage and current are inversely proportional. So voltage VP or VP by VS is equal to IP by IS by IP. So here V proportional to I, that is 1 by I. Inversely proportional. Voltage and current are inversely proportional. So VP by VS is equal to IS by IP. IS by IP. See, in previous case in turn ratio, VS by VP is equal to NS by NP is equal to K. It is a transformer ratio. It is a transformer ratio. But in the case of ideal transformer, VP by V is equal to IS by IP. But VP by V is equal to IS by IP. Now compare. VS by VP, NS by NP. VP by V is equal to IS by IP. If VS by VP is equal to IP by IS, is also equal to K. It's also equal to K. This is only for ideal transformer. It's only for ideal transformer. This is not ideal transformer. Vs by Vp is equal to Ns by Np. We cannot say it is an ideal. But this is exactly its ideal. Vs by Vp is equal to Ns by Np is equal to Ip by I is equal to K. So K represents turn ratio or transformer ratio. Transformer ratio otherwise can be written Vs by Vp is equal to K, Ns by Np is equal to K, but Ip by I is equal to K. See, Vs by Vp is equal to Ns by Np is equal to Ip by Is. So Vs by Vp is equal to K, Ns by Np is equal to K, Ip by Is equal to K. So Vs by Vp is equal to K turn ratio, Ns by Np is equal to K turn ratio, Ip by I is equal to 10 ratio. Suppose in the case, if I am applying input voltage 200 voltage, I am applying voltage across the primary is 200. Obtained voltage is 50. Obtained voltage is 50. What is the turn ratio? What is the turn ratio? I am applying voltage across the primary AC voltage 200 volt. Voltage obtained across the secondary is 50 voltage. What is the turn ratio? Turn ratio, that is voltage given. Voltage given. ES by EP is equal to turn ratio. Applied voltage 200 volt. Obtained voltage 50 volt. So obtained voltage ES or VS. So it is a 50. This is 200. 5 by 20. So 1 by 4. So turn ratio is 1:4. Turn ratio 1:4. Turn ratio always output voltage to input voltage or output turn to input current turn or input current into output current. So in the case of ideal transformer only, mind it, Vs by Vp is equal to Ns by Np is equal to Ip by Is. But this is not ideal. Vs by Vp is equal to Ns by Np, we cannot say it is an ideal. Only ideal we should compare. There the voltage is greater, the current is lesser. So Vs by Vp is equal to Ns by Np is equal to Ip by I is equal to K. This is the turn ratio. If turn ratio K, we can classify whether the given transformer is step-up transformer or step-down transformer. We know that. What is that step-up transformer? The voltage applied is at 200. Voltage obtained is at 50. So voltage reduce. Voltage reduce from 200 voltage to 50 voltage. So definitely the type of transformer is step-down transformer. Step-down. Down means high voltage convert into low voltage. If high voltage convert to low voltage, it's a step down. Suppose I am applying 11 kV voltage across a primary, 22 kV taken out across a secondary. So this is K means a kilovolt. 11,000 volt applied across a primary, 22,000 volt taken out across a secondary. So this kind of transformer is step up transformer. Up. 11,000 voltage, 11,000 voltage into 22,000 voltage. Here 200 voltage into 50 voltage. Where the voltage is applied and the applied voltage is lesser is step down. Applied voltage greater than the applied voltage is step up. Okay. By using the K value, we can find out whether the given transformer is step up transformer or step down transformer. K, we know K is equal to Vs by Vp. If Vs by Vp is greater than 1. That is a greater than 1. Vs at 200, Vp is 50. So definitely the value would be the greater than 1. So it is K value greater than 1, it is step up. K value greater than 1, it is step up transformer. Where the secondary voltage is greater, where the secondary turn also greater. Number of turns in a primary is 1000. Np is equal to 1000. Ns 500. It is 1000 number primary turns is 500, secondary turns is 500. So the kind of transformer is step down transformer. Primary transformer number of turns 1000, secondary turns 2000. So the type of transformer step up transformer. Where the voltage number of turns is greater, definitely voltage is greater. So a Vs by Vp greater than 1, K greater than 1. Where the K value greater than 1, type of transformer is step up transformer. Where K value less than 1, kind of transformer step down. Step down transformer. By knowing the value of K, turn ratio, we can classify whether the given transformer is step up transformer or step down transformer. So the transformer changes voltage and also the changes the current. So electrical energy, they convert to electrical energy. But in this case, primary frequency which is equal to secondary frequency, same time power across the primary which is equal to power across the secondary. In a transformer, power does not change, energy does not change, voltage changes, current changes. Voltage changes, current changes, but the frequency remains constant. Frequency remains constant, power remains constant, but the energy transforms from one part to another part. Energy transforms from one part to another part. In the case of ideal transformer, ideal always K is equal to 1. Ideal transformer K is equal to 1. How the K is equal to 1? That means input voltage which is equal to output voltage. Number of turns across the primary which is equal to number of turns across the secondary. Only those cases the K value is 1. But we cannot construct when the K value is 1. See, always we are constructing the transformer to transform the energy from one part to another part, either high voltage or low voltage. We are not using the input voltage which is equal to output voltage. If K is equal to 1, such a transformer is equal to ideal transformer. In ideal transformer, input power is equal to output power. So ES by VP, Vs by Vp is equal to K, 1. Ns by Np is equal to 1. Ip by I is equal to 1. So then ideal transformer, input power which is equal to output power. But K value is always equal to 1. But generally in practically, we are always getting the K value lesser than 1. K value always less than 1. Why the K value is always less than 1? Because of there is some loss of energy. Some loss of energy. Because of the energy losses in the primary, practically there is the K value always lesser than 1. So efficiency. The efficiency of the transformer not equal to 100%. Always lesser than 100%. Always lesser than 1. Because of that there is some loss of energy. What is the efficiency? How to calculate the efficiency of the given transformer? The given transformer in good quality, good condition. How to calculate efficiency? Efficiency of the transformer denoted by the symbol eta. Eta is equal to it is a ratio of eta, it is a ratio of output power into input power. It is a ratio of output power into input power. That is output power ES or VS IP by VP into IS. Input power. Power is a product of voltage and current. Output voltage. Output voltage VS. Sorry, output power. Power is a product of voltage and current. VS IS divided by VP IP into 100%. If VS IS divided by VP IP into 100%, it's always less than 1, but not greater than 1. Not greater than 1, always less than 1. Why the efficiency of the transformer is not equal to 100? That means ideal. It's not ideal. Not ideal. Because there are some energy losses in a transformer. There are some energy losses in a transformer. That's why we are not getting the efficiency is not exactly 100%. But practically we are constructing the efficiency of the transformer 96% to 99%. There is a loss of 1%. Maximum we are losing 1%. The loss of 1% the efficiency because of some energy lost in a transformer. We will talk energy loss in a transformer later classes. So far we have seen the transformer. The transformer is an electrical device which converts the energy. That means high voltage into low voltage. That means high voltage with low current into low voltage with high current. There are two kinds of the transformer. One is a step-up transformer, another one is step-down transformer. Step-up means how the voltage is given, how the voltage is obtained. The obtained voltage is greater than the input voltage, that is step-up transformer. Obtained voltage lesser than the input voltage, it is step-down transformer. So the two type of the transformer we have seen, and also the turn ratio. Turn ratio, the output voltage into input voltage or output turns in secondary to turns in primary, current in primary to current in secondary, the K value. So by using the K value we can determine whether the given transformer is a good quality or not. Good quality or not. In the case of ideal transformer, Vp by Vs equal to Ns by Np is equal to Ip by Is. Ideal transformer. In the case of ideal transformer, K is equal to 1. It is a step-up transformer, K greater than 1. Step-down transformer, K lesser than 1. Why the efficiency of the transformer lesser than 1 will talk later the classes. Thank you.